In this video, what we're going to do is solve an applied problem that includes some matrix operations. We have the scenario where Haircuts R Us has 3 locations, Edmonds, Shoreline, and Northgate, and each location offers regular haircuts and deluxe haircuts. In May, sales for regular haircuts were 84 in Edmonds, 75 in Shoreline, and 113 in Northgate. And then we have similar numbers for the sales of deluxe haircuts. Supposed to write the sales data as a 3x2 matrix. What we're going to do is we're going to make a matrix here. So it's 3x2. So the 3 is our rows and the 2 is our columns. So we're going to have 3 rows, 2 columns. Now, this tells us how we're supposed to organize our matrix, because in this scenario, we have 3 stores and 2 types of haircuts. Our columns have to be our types of haircuts, our regular and deluxe, and our rows have to be our different locations. So let's put Edmonds, Shoreline, and Northgate. Looking at our data for the regular haircuts, we have 84 in Edmonds, 75 in Shoreline, and 113 in Northgate. And then the corresponding data for the deluxe haircuts are 128 in Edmonds, 92 in Shoreline, and 145 in Northgate. There's our sales matrix. The next thing they ask us to do is to report the value of Q sub 1, 2. So remember, when we're dealing with matrices, we usually use a capital letter for the matrix name. And when we have Q sub 1, 2, first of all, that's lowercase, and these numbers here tell us the location that we're wanting. So the 1 tells us the row, and the 2 tells us the column. So it's row 1, column 2. So what we want is that number right there. So the number is 128. And then it says write a sentence that reports the meaning of this. So remember, we had regular haircuts and deluxe haircuts. So that's a deluxe haircut. And we had 3 locations. We had Edmonds, Shoreline, and Northgate. And so this is the Edmonds location. This tells us in May, the store did 128 deluxe haircuts at the Edmonds location. In this next part, it says the price of a regular haircut is $15 and a deluxe haircut is $25. What we want to do is we want to find a new matrix that represents the revenue for each store. Remember, here we have our Edmonds store, we have our Shoreline store, and we have our Northgate store, and these were regular and deluxe. And so if I wanted to figure out the amount of revenue for the Edmonds store, well, I know that each regular haircut is $15, and I have 84 regular haircuts, and each deluxe haircut is $25, and I had 128 of those. So these numbers here, this 84 and the 128, that represents a row. Remember, when we're multiplying matrices, we're taking the rows of the first times the columns of the, since I'm using a row of that first matrix, I know that that has to be in my first matrix. And what I'm trying to do is I'm trying to multiply it by this price data. That price data has to be a column in my second matrix. Let's just check to make sure this works in terms of multiplication wise. This is a 3x2 matrix. We've got 3 rows, 2 columns. This is a 2x1 matrix. These numbers are the same, so I can do that. And my resulting matrix is a 3x1 matrix, which is exactly what they told us they wanted. If you do the multiplication, you should end up with $4,460 for the Edmonds store, $3,425 for the Shoreline store, and $5,320 for the Northgate store. In this last question, it says the sales in June are half of those in May. So June must have been a bad month. Let's think about what this would mean. So if its sales are half of those in May, we're not talking about revenue, we're talking about sales. So we're talking about number of haircuts here. If we started out with 84, let's look at this number here, regular haircuts at the Edmunds store, and this was our May number, our June number is going to be half of that. So we're going to multiply this by 1/2. We end up with 42. Now notice, this isn't anything where we're multiplying a row times a column. We're just multiplying everything by 1/2. That is scalar multiplication. Our June sales are just going to be 1/2 times our May sales. And so we're just doing scalar multiplication with that scalar of 1/2. That's it for this video. Hopefully you found it helpful.